Hi everyone, I'm Johan. This is my second talk for the Go London user group. I've been writing Go for about 2.5 years. I work at InfoSum, a data collaboration startup out in Basingstoke. We're hiring. Come to me afterwards. I have a lot of open source projects, mostly involving gRPC and Gopher.js and some WebAssembly as well, as we'll see. And I've contributed to Go programming language. I run a blog writing mostly about gRPC. You should check it out. It'll be at the end. And I'm here today to talk about WebAssembly. So let's have a quick overview first. Today, we're going to learn about what WebAssembly is. We're going to use WebAssembly with Go, and we're going to show what's possible right now, or very shortly, with Go 1.11. And we're going to see, hopefully, what will be possible tomorrow. So let's start with WebAssembly. Oops. So who's heard about WebAssembly already? Show of hands. This is good. OK. So we shouldn't need to cover this too much then. So it's a web standard WebAssembly format, like an executable format. Runs in the browser. It has cross-browser support since May, I want to say, or something like that. So if you write WebAssembly today, all modern browsers support it. It's intended for fast numerical calculations, but obviously it lives in the browser as well, which means that if you hate JavaScript like you should, then you can maybe use WebAssembly instead, eventually, at least. So today, it has a JavaScript interface which you can send information across if you want to access JavaScript-specific APIs, which is basically necessary if you want to get anything except for writing to the canvas done. So we'll see some examples of that. And so yeah, hopefully it could eventually replace JavaScript, or at least make it possible to write web apps without JavaScript. So what does this have to do with Go? So let's take a sidestep first. Who's heard of Gopher.js before? Yeah, it's not nearly as many. What? Come on, guys. And OK, so who's written some Gopher.js? Yeah. Come on, where's Paul? Come on. Paul, yeah, very good. OK, so Gopher.js is a third-party tool that compiles Go to JavaScript. It's great. You should check it out. It's existed since about 2015, so you've already had the choice not to write JavaScript, essentially, and you haven't had an excuse if you haven't used it, and you've been writing web apps. So it was written by a guy called Richard Musial. It's amazingly clever, and Richard is a true genius, and we'll see later on again why he is. Supports most of the standard library. It has many web bindings, bindings for existing web technologies, such as React, and Vue, and browser APIs like the Fetch API. So you can write a lot of stuff in Go and compile it to JavaScript and run it in the browser today already. But, of course, in Go 1.11, you'll be able to use WebAssembly instead. So, also written by Richard, the guy couldn't stop after writing implementation for JavaScript. He said, you know what, WebAssembly, no one is picking this up. There's been an open issue for like 1.5 years, and he was like, on a weekend or something, by the way, I've started implementing this myself. And everyone was like, wow, okay, so like all of these technical problems we've been discussing, cool, I'm so grateful. So yeah, Richard basically implemented himself completely insane when you think about it. He's going to support that himself as well, but I'm sure there will be people helping me out with that. So I was showing on the previous slide what you run with Gopher.js to generate the JavaScript file, but with WebAssembly, you can run Go build itself to generate WebAssembly. It's just another compilation target, and maybe a bit curiously, we have the JavaScript operating system and the WebAssembly architecture. Now, there is reasons for this. I can't remember why, but you could basically do this the other way around. I don't know. It makes sense on some level. So it supports most of the standard library already, including making network requests, which is cool, I think, because that's not really what WebAssembly was intended for. But you can write something today using HTTP net package to call web requests from a WebAssembly client. So how do we use it? It requires a little bit of setup to get working. The Go 1.11 release comes with these files, wasm.exec.html, which contains some HTML for you to load the generated WebAssembly file, it's a short file, and then wasm.exec.js, which is completely mandatory and has logic for translating data between WebAssembly and JavaScript. So the wasm.exec is essentially just like this is what your index file should look like if you want to load WebAssembly, and wasm.exec has to be included with your generated files. So in the demos that I am going to show you, it's all kind of done automatically using a Go generate script. Thanks, Nick. Also, secondly, browsers don't like it when they load a WASM file and it doesn't have the correct content type set. And apparently, so there was never mind, that's going to take too long. Just do this, right? When you have a WASM file, just set the content type, and the browsers will load it successfully. Okay, so that's enough theory, right? If you've seen any of my talks before, you'll know I like to do some practical examples. So I've got to try and drag my VS Code window over. Come on. Oh boy. Okay, is that big enough for everyone? Thank you. Okay, great. So we're going to have to kind of code sideways here because I don't want to duplicate my screen. But what we got here is a simple hello world, of course. I thought we would just show that to start with. Just a couple of points. We've got the build tag here, which means we only compile this when we're running for the JavaScript operating system and the WASM architecture. You probably want to put this on the top of your files, but you especially want to put this on the top of your files if you're compiling it in the same code base as other compilation targets. So just like in Gopher.js, a binary WASM file requires a package main to know where to start execution. So we've just got an import hello world here, and what do you think format.println maps to in WebAssembly? We'll see. So I've got make hello there, which you can see it runs the latest release candidate and copies across the files from the relevant directory. And then we'll run make serve, and let's see. Oh, that's the one. Is this the right place? No. Oh. I have to transfer my Firefox page across as well. Curse you. Okay, let's reload this page. Yeah, okay, so the wasm.exec default HTML file comes with a helpful run button that you can press if you want to do something. So we've got the run button. It's loaded because this run button is activated, and we're going to press it, and boom, hello world, indeed. So not all that interesting, but that's a small hello world example. Okay, so I stole this one from the Go tour, just showing that you can use channels and things in Go routines. So let's run that one. It compiles the correct directory, and then we do make serve again. It's all just serving from the same directory. Reload the page. It loads really quickly in Firefox. We'll show this in Chrome in a second, and then you'll see it takes like literally seconds to load WASM. Unacceptable. So that does things. I don't really know if that's proof enough to you, but let's get a little bit more interesting. So I talked about the JavaScript interface that we have. So here's an example of how to access the document object model and add a div element and write something into it, which is a bit more interesting than writing to the console. So let's open the terminal again. Let's make JS. That one also did a little nice sed script to insert a div which we can target. And let's see, we shouldn't need the console anymore. Hey! But wait, there's more. Wow. And then for the next example, wait a second, where's my... No, actually, we'll do this one first. Here I've imported a DOM package, which encapsulates a little bit of this interaction with the DOM in a nice Go wrapper. I've written a DOM element IO writer, which implements the IO writer and writes to a new element every time you call it. And then I have created a standard library log with that right there, of course, by first getting the correct element from the DOM. And then what I've done here is created a HTTP client. And I'm going to call a HTTP request to HTTP and see what happens. This should totally work. Oops. Okay, and we'll open the network tab for this. Ah, we have stuff. This is the JSON reply from HTTP. But as you can see, under the hood, this calls to the browser fetch API, a post request. Now, this website takes a long time to reply. It's probably written in PHP or Python or something like that. Wouldn't be written in Go. It would have replied in literally milliseconds. That's the fetch example. I just wanted to show that you can use the network. The only requirement is that you use the default transport. The default transport round tripper is implemented in the standard library in Go 1.11 using the fetch API. So yeah, just like a HTTP .post or HTTP.get would have worked as well because it uses that transport by default. Oops, what's next up? I had an example for, where is, no. Let's see, I've lost a file, I think. Ah, no, there it is. Oops, oh shoot, that's not. Wow, I moved my entire vendor directory. This is not scripted. So, here I have another simple thing that accesses the, the DOM and writes to the body itself. But what I wanted to show here was that if we make build JS Go, this one runs a tool called wasm Go and deploys it to Dave Brophy's fantastic jsgo.io website. So we don't have to host the WebAssembly ourselves. So as a bit of background, WebAssembly generates huge files. And this was kind of true for Gopher.js as well. But JS Go is a tool that splits by package and then caches packages so that if you visit several Gopher.js websites, then you'll be able to just download the things that you don't already have in your cache. We want to do the same kind of thing for WebAssembly eventually, and work is underway. Where's Dave? Dave is the one who is doing some work on that, and that's super exciting because then eventually like a 2 megabyte or 4 megabyte or 10 megabyte WASM file might be split into several much smaller files that you already have in your cache and are hosted on CDNs, so your WebAssembly code isn't completely hopelessly slow. So that one created a file, it uploaded it on a GCP bucket, I think, and ran it. So in the future, it might be as simple as just implementing a WASM, implementing a file like you saw there, running this wasm Go deploy, and it gives you a website that you can load it on. So this simple thing, just call deploy, it's deployed, and this is obviously available via Cloudflare. All over the world, everyone will be. Yeah. It'll be easy to download for everyone all over the world. Whew, should have tested this one. Okay, so the last example I wanted to show was a little bit more advanced, but just to give you an idea of what you can actually accomplish. Now, I mentioned at the start that I'm kind of interested in gRPC and stuff, and the first thing I wanted to implement with WebAssembly was gRPC-Web, which is kind of a tall order, but it turns out it's completely possible. And what I did was I forked the gRPC library and I implemented it under build tags so that when you're making a Go client and compiling it with WebAssembly, it just automatically builds a gRPC web client. So this protofile here defines the server backend and the client interface, and we'll see there's a universe method and the streaming method. And we'll just take a quick look at the back end. Implements the generated interface, and the front end, which is written for WebAssembly, just imports Google gRPC, imports the proto file, of course, and then we've got this div writer again, and basically you just call gRPC dial with nothing if you're hosting it on your own server, create a new backend client. This looks just like any other gRPC client, but the cool thing is now we'll be able to compile this with WebAssembly and run it in the browser. So this, actually, we want to have the network page open, I think. Wow. Yeah, so that made a couple of requests. It's kind of logging things here. This one in particular will look much nicer in Chromium, actually. So, let's do this without the... Wow, this is way too large. There we go. So when I pressed the button, it made a couple of calls to the backend server, returned the information from the backend, and this in Firefox, this streaming method actually blocks until the whole method returns. But that's just because Firefox is slow in implementing fetch streaming. Oh wow! Okay, let's reload this page. Let's look at if you look at the network invocations here, then it's just sending binary protobuf data back and forth with a content type gRPC-Web. It's all just working, which is awesome, I think. Let's see if I can just show you the Chromium version, because let's see. There we go. Okay, yeah, look at how slow this is to load. It's not loaded yet. Wait. There! Unbelievable. And here, you'll see that the reply is streamed back. Amazing, right? You gave me an applaud for the other thing? This is the cool thing. This is so cool. Anyway. Okay, so let's go back to the presentation, because there's actually another thing that you guys might like more. Oh, okay, it's here. Where were we? Yes, those were the examples. Now this is an iframe of a, oh my god, is that lagging? No? That looks totally shot on there. Oh wait, it's because I'm in the wrong browser. Let's just do it here. This is implemented with WebAssembly with a canvas written by Luis Figueiredo, I'm not sure. And the source code of the whole thing is in the background. This is like so cool. It's not that large. It imports like OpenGL libraries and things and writes to the canvas. But it goes to show that you can do these kind of graphical things as well with WebAssembly. And you've got the FPS counter up there. You can like adjust variables on the fly. Like, this is super cool. So, okay, we've looked at some of the demos. There we go. Okay. For the future, obviously no one today actually writes JavaScript. They write React. So, in the future, hopefully, people are working on things like WASM frameworks. There's already a Gopher.js framework called Vecti, which kind of never took off because Gopher.js never took off. But adapting it for WebAssembly might be super interesting. I know Brian Kettelsen and a lot of other people are really interested in doing this kind of thing. Brian, obviously, one of the organizers of GopherCon in the US, he's a huge proponent of WebAssembly. As I mentioned before, package level caching would be huge because large files is going to become probably unacceptable when it comes to deploying these things. But if we can get that working reasonably soon, I don't see any real reason for us not to kind of take off and overtake JavaScript and rule the world eventually. Native browser API. So all of the things that we've seen today basically go for the JavaScript bridge, which means copying data from the WASM world into JavaScript. WebAssembly doesn't have a way of doing this efficiently yet, but because it was implemented as a minimal spec, essentially, it's already in the pipeline. to have things like direct access to JavaScript objects, so you won't have to copy between them. Maybe eventually we'll have direct access to the fetch API, direct access to all those to the DOM modifications itself. So you won't even have to worry about writing a JavaScript wrapper for anything. You just go. Garbage collection is something that WebAssembly is eventually going to implement. I put a question mark there because what does that mean for Go? We already have a garbage collector. It might mean that we just kind of don't compile the garbage collector and we use the one in WebAssembly. No one really knows. Threading, also kind of what? We already have goroutines. Obviously, wasm only supports a single thread at the moment, but goroutines totally already work. So that's really exciting. Those things are like approved and will be implemented. So continual improvements to the Go implementation itself will take place, obviously, in the standard library. Pay attention. You can subscribe to issues for the wasm architecture on the official Go tracker. Obviously, raise your own issues if you're having problems. Help implement new features. Be really cool. And so let's take a step back and just summarize what we've learned today. So we've seen a couple of examples of using WebAssembly with Go. We've seen what's possible, and hopefully what will be possible tomorrow in terms of caching, garbage collection, threading, and I'll include some links here for further reading. The top link there is the Scylla document on WebAssembly. The second link is talking about proposals and RFCs essentially that have been accepted that will be implemented in browsers imminently. And I suggest you join the WebAssembly channel on the Gopher Slack. It's a lot of interesting talk in there already every day about the package level splitting and the new wasm frameworks and things like that. All right, so I'd like to thank Richard for giving us this beautiful port of WebAssembly. Thank you, Richard. Gopher.js was amazing, but WebAssembly is even cooler. It's amazing what a single individual can do. I'd like to thank Pivotal. We use Gink at work. Pivotal, that's really cool. Thanks for hosting us as well. And the London and Utility Warehouse, of course, for sponsors. Thank you. And the Go Meetup organizers. You guys do a fantastic job. I know it's a lot of work. Thank you. And I'll take any questions.
Actually going to go for a world first for LondonGophers and take a question from the internet.
Ooh.
Yeah, it could go disastrously wrong.
Sweet.
No, Christian asks on the YouTube channel, how are core specs for errors displayed and is debugging possible?
Ha! This is a great question. It's how are errors displayed and is debugging possible? So the answer to that is not really. It's like super hard, actually. It's probably one of the biggest problems with WebAssembly in Go at the moment. You get like, you can get like a trace, but it's usually something like invalid value or something in the JavaScript translation layer, and it's like super hard to debug. So yeah, that I don't know if you can run a debugger. Maybe I don't have an answer for that. But like generally, when you're writing things, you like try to write it, and it will fail, and then you will fix it. And they will fail again, and then eventually you get it right, and you'll be like, I hope this like doesn't break. It's at that stage at the moment.
We have one more question out in the crowd.
Ooh, risky.
Oh, sorry, Pivotal.
I'll repeat it.
Yeah. So we use gRPC quite heavily at Utility Warehouse. Generally, but where we need to access those endpoints from the browser, we tend not to be streaming, so we usually tend to front that with just an HTTP endpoint which is JSON or something like that. Do you think we're taking the most sensible approach at the moment? And when, if ever, do you think it would be more sensible and idiomatic to use Go compiled to WebAssembly into the browser to do it?
WebAssembly is certainly not ready for production. Gopher.js, maybe, but probably cutting it a bit as well. But that's not the only alternative you have, actually. There's a couple of Improbable people here, and they'll all be like laughing already because Improbable released this library called gRPC-Web, which implements gRPC from the browser, but in TypeScript. So you can like have your engineers who love writing TypeScript just import a gRPC-Web client and generate files for that, and just have all the benefits of gRPC from the backend in the front end. And obviously, you can avoid streaming if you want to, but it supports server-side streaming and actually bidirectional streaming as well if you want to. But you can just do unary request. But the good thing about that is even if you're not using all the benefits of gRPC, the benefits of having a typed interface is like you cannot understate that. You must have already noticed that in the backend. If you're using JSON between the backend and the front end, I suggest trying it. gRPC-Web, it's you can Google it. Yeah. This seemed like a good idea.
That's what I was worried about. Okay, we'll take one more quick question.
With your WebAssembly, is anybody talking against the Node VMs?
So I think Richard actually developed WebAssembly using the Node. So, oh, sorry. I'll repeat the question. Is anyone trying to? I didn't do that. I don't have a button for that. Is anyone trying to run WebAssembly on the Node VM? And so yeah, you can. You can actually even run the Go-generated WebAssembly code. Another file, I didn't include it here because I'm not interested in Node, to be fair, is another file that's included in the MISC directory together with wasm exec and wasm.js is something like JSexec or something like that, which literally takes a generated wasm file and runs it in Node. And I think Richard Musial uses it for development and testing and things like that. And I think eventually, maybe even the standard library will use that kind of thing for testing these. Frankly, the WebAssembly stuff in the standard library, the JavaScript specific stuff that I implemented in the standard library has no tests for it because there's like no way to test it because they can't run a browser in the trybots. So eventually they want to run a Node interpreter probably, which polyfills fetch because Node doesn't have fetch either. But it doesn't have any tests at the moment. And Brandhorst is like, okay, let's just, it's only experimental, this release. So contribute a Node interpreter for the Go trybots, and we can write some tests for it in the standard library.
Awesome. Thank you very much, Johan.
Thank you.